For the trig question, we're being asked to rewrite this in the form r cos theta minus alpha. And you know this is going to be on the exam, 100% guarantee of this. Grab your formula book to start with. So we write this out. R cos theta cos alpha. And remember the plus one, the cos one's got the opposite side there. So plus r sine theta sine alpha. You notice that the cos alpha here matches the cos alpha here. There is an invisible number there. There's a 1. And so r cos alpha equals 1. And do it the same on the other one. R sine alpha equals 8. Now you don't need to do any of that to find out what r is. R is just the square root. Using Pythagoras, this one squared add this one squared. So r equals root 65. You're not going to get that one wrong. But this one here, if you don't write that out, you sometimes get it round the wrong way. We want to do this sine 1 divided by this cos 1. So that gives us tan alpha equals 8. And this one is in radians. So if we inverse tan 8, then we're going to get 1.446. Write out the answer just in case they want it. It does say write it in the form of this. So we've got root 65, the cos of theta minus 1.446. I've seen that Dr. Mark in the previous exam paper when you didn't write down the last line there. So 3 marks for that. And then this really creative part for the next one. We've got a sequence cos x and then cos x, this time plus 2 sine x. And then cos x plus 4 sine x. So each time it's going up by an extra 2 sine x's, and here to here another 2 sine x's. So it is an arithmetic progression with the first term equal cos x, the difference equal to 2 sine x, and they're asking us to find out the sum of 9 of them, just like in the mock. So the formula for the sum of 9 of them is n over 2, so 9 over 2, lots of 2a, so 2 of those ones, plus n minus 1d. So n minus 1 is 8. 8 times 2 makes 16. 16 sine x's. Now last time this was identical to what we'd done earlier up here. This time it's not. This time we've got a 16 where the 8 was, and we've got a 2 where the 1 was. So this time we've got 2 lots of. And I'm not going to write out that thing there. We're going to look at this one here. We've got 2 lots of root 65, the cos of theta minus 1.446. So the highest, the maximum that this cos could ever be is 2 root 65. Times that by 9 over 2. It tells me that the maximum that could be is 9 root 65. This bit here, the 2's cancelling out there. And when does that happen? Well, it happens when the cos is at its highest, and the cos is at its highest at 0. So that means this needs to be 0, and theta would have to be 1.446. I might have mixed up thetas and x's there. I think I did. That should be an x. That should be an x there.